programme, we're going to discuss the lovely ringed planet Saturn. And at this moment, in my observatory, my telescopes are being made ready in the hope of a clear sky. But first of all, our usual news notes with Chris Blintott. And of course, Mars very much in the news now with the arrival of a new American probe.
That's right, this is Mars Reconnaissance Orbiter, which will spend the next several years studying the atmosphere, the weather and the surface of the planet. It's due to enter orbit on March the 10th, so let's hope everything goes well.
Meanwhile, down on the surface of Mars, those two amazing rovers, Spirit and Opportunity, are still going strong.
That's right, they're just about to enter their second Martian winter, which is a difficult time. They don't get as much power as normal, so scientists are really trying to get as much as possible from them now. Spirit is at an area called Home Plate.
What is it?
Well, it looks like a baseball diamond, apparently. It was visible from orbit, and it's not clear what it is. It could be a volcanic feature, some strange impact. Spirit's finally reached this point, and it's discovered this outcrop. And you can see many different layers of rock. So the plan now is to go up close, study that, and really work out the history of this strange feature.
Plenty of evidence now of past water there.
That's right, from both the rover sites.
Yes,
so it's clear that water was abundant on Mars. And it's not just the rovers. We've got amazing results from Mars Express as well.
These pictures are quite incredible. Phlegethon, for example.
That's right. This is an area just south of a large volcano which pops up at several kilometres above the plain. And what happens as that upheaval occurs is that material such as this is cracked and regions drop down, and you can see that quite clearly in this image.
So I think my favourite picture so far is Juvente. Juvente Chasma.
This is wonderful. This is a sulphur mountain, first seen in the images and then confirmed with a spectrograph on board the spacecraft.
Looking further afield still, dark matter, still very much in the news.
Absolutely. For many years, astronomers have had a problem with spiral galaxies. They just rotate too quickly to be explained just by the luminous matter that we see. So we've suggested that they're embedded in a whole host of dark matter. We see its gravity, but we don't know what it is, and we don't know its properties.
It's definitely there, but what it is really have not got the faintest idea.
No, so the important thing to do is to gather new observations to try and understand this. And a team involving astronomers from Cambridge have done this by looking at small galaxies near our own Milky Way, dwarf irregular galaxies. And what they've done is look at the motion of stars in those galaxies. And those stars are responding to the gravitational attraction of the dark matter in those galaxies. And they've discovered that it's not clumped in the centre. It hasn't all cooled and fallen into the centre. It's spread out. If that result is confirmed, that has incredible implications. It suggests that the dark matter is made of particles that are moving reasonably quickly. It completely contradicts everything we thought we knew about dark matter, and it means we've got to do some serious thinking.
But particles of what type? This is what we don't know.
We don't, and most of the candidates that have been proposed are what we call cold dark matter, slow-moving particles. If these results really are contradicting that, then we really are left without a clue as to what dark matter might be.
I think this is probably the greatest problem facing us now.
It certainly is, and huge numbers of people are working on it. Maybe we'll get an answer soon.
Maybe, maybe not. We must wait and see. Chris, thank you very much.
A pleasure.
And now, on to our main programme, the lovely ringed world of Saturn. It's a giant, more than 70,000 miles across. And it goes around the Sun at a distance of nearly 900 million miles. Even so, it looks bright, brighter than any star. Not solid, of course. It's made up mainly of gas and liquid, and the actual density is less than that of water. It's said if you could throw Saturn into a vast ocean, it would actually float. Of course, the main glory of Saturn is its ring system, made up of small, icy particles spinning around the planet in the manner of miniature moons. And Saturn has a whole satellite family of its own, and some of the satellites are big enough to be seen with small telescopes. Well, those are a few facts about Saturn. And now, out to my observatory. Chris, can you see anything?
Well, Patrick, sadly, it's completely cloudy. But Pete, you've got some images of Saturn taken just a few weeks ago.
That's right. I've been watching Saturn this time round, and I decided to try using a video camera, a special video camera optimised for astronomy. And that's quite a good representation of Saturn as you would see as an amateur looking through a telescope.
Oh, it's a beautiful object, isn't it?
It is. When you look at Saturn through a telescope, that's the hook for a lot of people to bring them into astronomy.
Well, it was for me, certainly.
It was for me as well, actually. But it is a superb object to look at.
And the first thing you notice are the rings.
That's right. The rings are very striking around Saturn. You can see the shadow of the planet on the rings, and you can see the gaps in the rings, or one particular gap, which is the Cassini division.
Now, what are the rings made of?
Well, we know they're made of ice, at least predominantly ice. We can tell that from their spectra. And they are typically sizes of about a few centimetres across, bigger in some places, smaller in others. There's actually a whole spectrum of sizes.
And the rings are actually very, very small indeed.
We really still don't know the dimension. It may be perhaps as thick as the largest ring particles, so perhaps a kilometre or so. But there really is no way of knowing so far exactly how thin they are. But the extent is just enormous system. 130,000 kilometres out to the edge of the A-ring gives you some idea just how thin these rings are.
It's been suggested that they're the result of a moon which broke up. Is that the case?
That's possible. If you put the entire ring material together, you would get a moon the size of one of Saturn's smaller moons. So that's possible. So we can actually get a spectacular ring system from not particularly large object. Another theory is that it's a passing giant comet. You can't be talking about something like Halley's size. You have to be talking about something a lot bigger. That perhaps there are reservoirs of these in the outer solar system, and every so often they come in, get close enough to Saturn, and then get broken up. Perhaps that's a way of renewing the ring system. That, say, we're just looking at the latest version. They may go, and then we get another comet comes in and gets broken up, and so on.
And of course, the other obvious feature, even in a small telescope, are the moons.
Are the moons, they're absolutely lovely around Saturn, because there's quite a large number of moons, and they're quite easy to see with a fairly modest telescope. Titan, of course, which is the brightest of the moons around Saturn. But then as you move in towards the planet, there are all these tiny moons which are moving around, and they're very easy to pick up.
Well, it's a fascinating world, but to get a close-up view, nothing beats actually going there. And robotic probes have been doing that and sending back pictures since the 1970s. Patrick's talking to one of the scientists who's been involved right from the beginning.
Well, those early probes altered all our ideas about Saturn. I'm delighted now to welcome back Professor Gary Hunt. Welcome, Gary.
Thank you, Patrick.
Those voyagers, well, you were so much concerned with them.
Well, indeed, it was a major part of my life, but the important thing about these missions was it was beginning to open up the outer solar system to give us a new perspective of what was going on there. But let's go back to the first reason that we were going there, not just to look at Saturn and compare with Jupiter, but could we get to Titan?
An orange blob.
Well, the important thing about Titan was could we get a spacecraft there? And really what we found, which of course we've now, Cassini and Huygens have been able to push further, was we found, yes, it looked a bit orange, there was definitely an atmosphere, we couldn't see the surface. It raised more questions than it really answered. But the important thing was it showed another mission was possible. But that wasn't the only atmosphere we were able to look at. We were able to look at Saturn itself and to see some very distinctive cloud features, very high speed weather systems around the equator, and to be able to compare that with Jupiter.
What about those strange spokes in the ring? We don't really understand them even now.
That was the whole thing about the Voyager mission. It was a chance to look at the rings in more detail. Yes, we found more detail in the rings, but we didn't expect to find small satellites. And the spokes, well, we again have no idea what they are today, and we were certainly very puzzled then.
And no question at all, the Voyagers have got a firm place in history.
Well, I think they are the foundation to a modern understanding of the outer solar system and the planets. But it's not all over. Analysis of the data is still going on today. And there could well be more discoveries coming now from the observations taken by Voyager 25 years ago.
Gary, thank you very much.
Thank you.
25 years ago, Voyager. Now we have Cassini going around Saturn and sending back data. And in my observatory, Chris is talking about it to Professor Carl Murray.
Well, Carl, Cassini's about halfway through its initial tour of the system, and it's had quite a journey.
Yes, it's been spectacular to say the least. We came in, of course, from Earth, so we come in the plane of the ecliptic, plane of the solar system, if you like. But Saturn's equatorial plane is tilted to that. So with respect to Saturn, we've come in on an inclined orbit, and therefore we've had for some time quite a good view of the rings. Unfortunately, that is now finished, at least for the time being, and we're almost in the exactly equatorial plane of Saturn at the moment. So we get a good view of the planet and satellites passing one another from our viewpoint, but we don't get out of the ring plane again until the end of summer this year.
Well, let's start with the planet then. And Cassini's had a view like nothing we've ever seen.
You're absolutely right. It's been amazing to be in orbit around the planet, studying the the weather systems, for example. Now, we've seen something really spectacular. We've seen storms, beautiful system. There's what we call the dragon storm that we saw with our images.
It's an incredible image.
It is. We've seen this storm evolve and disintegrate before our eyes. We've also, of course, detected the storm that was first seen by the amateurs in January. We, because of the long orbit that we were on, were looking at a sort of crescent of Saturn, whereas the amateurs, the view from Earth, gives us almost a complete disk. Now, we did do something with Cassini on the dark side, using actually the ring shine, sort of reflected sunlight to image what we think is the storm system. We haven't seen any lightning that the plasma instrument is picking up, but we're pretty sure this is the same storm system.
And it's amazing that we could detect lightning on Saturn.
Yes, we've got special sequences planned in the future that we're actually going to try and image the lightning as well. But of course, as with imaging lightning on Earth, you've got to have a certain luck element in all of this. But we certainly plan to do that and continue observing these storm systems. We've recognized that in about 35, 36 degrees southern latitude, we call it Storm Alley. We see these storms develop and evolve and die. And it'd be really interesting to know what the source of this is and how it's, again, related to the orbit of the planet around the Sun.
Well, there's one important point is that Cassini is in orbit around Saturn. It's the first craft to do that, so you get to watch things evolve over time.
This is the beauty, we're in orbit for at least 4 years around the planet, so we get to see evolution.
So there's surprises wherever you look, like the aurora on Saturn. Who would have thought we could see that?
Exactly, and we see, the parallels with Earth are right there. We know we have the aurora, the North and South polar regions. We can see that again with Cassini.
And let's come to your own work on the rings, and the results here are just as interesting as anything on the surface of the planet. These are images of the F ring just outside the main ring, and what on earth is going on here?
Well, that's what we're trying to understand. We know that Prometheus and Pandora, the shepherding satellites on either side, have a gravitational effect on the F ring. We know that this moon Prometheus, one of the two F ring shepherd moons, actually directly interacts with the F ring, goes in every orbit, pulls out material just by pure gravitational attraction. That material then goes back into the ring. There's a channel created, and those channels shear. And we can actually see these in the images. As we look around the ring, we can see the effect of Prometheus. But we also believe, based on our images, that there are small moons orbiting within the F ring. Now, we think these moons are, well, we actually don't even know if they're moons. They may well be just temporary clumps of material. You can see one moon here, one object, which appears on the outside, and we believe that's the same object that later on appears on the inside. So this is it's not really a shepherding moon. It's sort of, the sheepdog's gone a bit wild here. It's sort of crossing through the ring. The general conclusion we're coming to is that we're really looking at a young ring, maybe even formed at the same time as Prometheus and Pandora. And we're just looking at the remnants, because over the age of the solar system, this should all have sorted itself out. The rings would have collided with the moons, the rings would just settle down, maybe the ring would have disappeared altogether. And yet we're seeing a very dynamic, very unusual ring system, and one that's posing a lot of problems for us.
And you can see what has been suspected for a long time, that each of the gaps in the ring seems to be associated with a moon.
That's right. We knew that the Encke gap, which is in Saturn's A ring, was associated with a moon Pan. We had suspicion that because of wavy edges on the Keeler gap that we just about detected with Voyager, that there was also a moon there. Sure enough, that moon has now been detected. That's now called Daphnis. But there are other gaps in the rings. And again, our best theory is that these are caused by small moons that we have yet to detect.
And what about one of the mysteries of Voyager, the spokes in the ring?
We'd seen these spokes with Voyager. We knew they were probably caused by dust particles, perhaps elevated above the rings, because whether they appear bright or dark depends on the viewing geometry and whether you're looking on the lit side or the non-lit side. Now, we'd been looking for these with Cassini. We'd set aside special times to just stare and look for these spokes. Saw absolutely nothing until the end of August, beginning of September last year, when all of a sudden the spokes appeared. Unfortunately, it was at a time just as we were ending the initial inclined orbits and going down into the equatorial plane, so we haven't had a chance to go back and look and follow these things, because many people predicted that we weren't going to see spokes until the Sun was almost in the ring plane, which is going to be in near 2009. And that would replicate the sort of geometry we had at the time of Voyager.
We've got several years left. What else do you want to know? What are the big questions that remain?
The really big questions relate to, as they always have done, to the origin and evolution of the rings themselves. where do the rings come from? Are we looking at a single event that caused them, or is it multiple events? And how long will the rings last?
Well, I can't wait to see the next 2 years' worth of results from Cassini. Meanwhile, the amateurs will do what they've always done. Keep an eye on the planet night after night and look out for developing storms. To find out more, Patrick's outside.
We've seen those superb pictures, and I'm glad to say I'm now joined in my observatory by 3 of our best amateur Saturn observers, Damien Peach, Dave Tyler, and Ian Sharp, and they're doing splendid things on Saturn. First of all, Damien, may I come to you? I remember the white spot on Saturn in 1933, discovered by Will Hay. Well, there's been a white spot now.
There is a white spot now. Here we can see 4 images of the great white spot that erupted on Saturn in 1990, which is the same kind of spot that occurred in 1933.
I remember that one very well.
That was a massive eruption of clouds on Saturn, and this was actually discovered by an amateur astronomer in September 1990.
Mr. Wilbur.
And it spread around the whole planet over the course of weeks, and it's one of the largest eruptions that's ever been photographed on Saturn. There have also been other storms to occur on Saturn, and we see here some images from 1994. A white spot has erupted in the equatorial zone of Saturn. These kind of storms periodically occur on the planet over the course of several years, but these large eruptions typically only occur every 30 years. There was also another large storm on Saturn in 1996, but neither of these later storms were to the degree of the massive 1990 storm. Moving on sometime later, we have 3 images presenting colour changes across the globe of Saturn between the course of 2004 and 2005. Here we can see that the colours gradually change across the course of time. This is due to chemical changes in the upper atmosphere.
Well, Dave, you've been following these, haven't you?
Yes, we have, and we've got some nice pictures of them. On the very first image here was taken by simply holding this up to the eyepiece of a 6-inch refracting telescope. And then I stopped using this and I put a webcam in there, and immediately the pictures improved dramatically, but the colour is still not quite right. Now I changed from the 6-inch refractor to this 8-inch reflector, and immediately the colours were just right.
Ian, what's the latest news? You've been observing Saturn also.
Yes, indeed, and this image is an image of the latest storm that is actually around on Saturn now, and we were hoping to get an image of it this evening. This was taken on the 10th of February, just a few days ago, and it shows the storm quite well. It has sort of started to smear out slightly as it's getting older, so it is changing over time.
I wonder how long it will last.
Well, that's an interesting question. They vary, but this one has been around for a good couple of weeks already, and hopefully another couple of weeks or a bit longer. So we're keeping an eye on it, and it is spreading out as it ages.
You know, pictures like this are lovely to look at, and also very valuable, because this picture, far better than anything could have been taken with any telescope when I began the Sky at Night programme.
Absolutely, yes. It is incredible that technology allows us amateurs to actually get better images now than I could ever have seen when I was a boy, for example, looking through the best images that were published.
Well, they are splendid pictures. And in my view, you know, Saturn is the loveliest thing in the sky, with the disk, those marvellous rings, and of course the family of satellites. It's a large family. Iapetus, the outermost of the fairly big icy satellites, more than 2 million miles from Saturn, and then further out still, about 8 million miles, Phoebe, a strange world going on Saturn the wrong way and almost certainly coming in from the outer solar system. And beyond Phoebe, more newly discovered very small satellites, almost certainly ex-asteroids. So that makes a very varied family. Well, I've come back out of the cold into the warmth of my study, and so has Professor Carl Murray. And we're joined now by one of our most regular and welcome visitors, Professor John Zarnecki.
Hello, Patrick.
Well, we must, I think, begin with Titan. Bigger than our moon, with a dense atmosphere, a weird world. What's the latest news?
We're now at a stage where we understand some of the basics. For example, we understand, at least at the part of Titan where Huygens descended, the structure of the atmosphere, you know, the temperature, the pressure profile, how the density varies.
What is the main atmosphere? Nitrogen?
It's nitrogen, yes, with, of course, methane, hydrogen, and then this whole array of hydrocarbons, these increasingly complex molecules, which, of course, is one of the main reasons why Titan is so interesting.
Any liquid there?
Now that's the tantalising question. We don't see any standing liquid from the Huygens data. However, I'm absolutely convinced that it was damp where we landed. You know, I think there's very strong evidence that the icy sand that we landed in was damp. So there was liquid there. Was it a week ago? Was it a year ago? Was it 100 years ago? We don't know.
Does it rain on Titan?
Yes, clearly it does. I mean, we have these wonderful images of these drainage channels, and some of the latest results, which we can see here, actually show a 3D reconstruction of this system of dried up rivers. It's about 5 kilometers to the north of where we landed. And the camera people, by taking different views from during the descent, have produced this sort of 3D image, which we can see. It's as if we're flying over it. And we can see these gullies and channels, rather steep-walled ones, which I think means that when it did rain, the rain was pretty violent, and they produced these steep gullies.
Titan has a deep, dense atmosphere, and it's windy there too.
It is indeed, and we're beginning to understand the structure of the wind. In fact, we've got a sound file here, which I think we can play. Now, this represents the signal that Cassini received from the Huygens craft, and it's been converted to sound, and you can hear now Huygens is beginning to slow down as it decelerates at the top of the atmosphere from 20,000 miles an hour down to a much lower speed. There it is, it's changing, and now it's under the parachute, and it's now subject to the wind. It's being blown about by the wind, and by analysing the subtleties of this signal, we can work out the wind speed, the wind direction. There it is hitting the surface, and the signal changes completely.
What are the wind speeds?
Well, high up in the atmosphere, it's of the order of 100 or hundreds of meters per second, but lower down, really a gentle breeze at the surface.
Is there any activity going on there now?
One effect there's some tantalizing evidence for is some sort of low temperature volcanism. There is some evidence that material is seeping up through cracks, through ridges, maybe even through something that we might call a volcano, but of course a low temperature effect.
Yes.
And this might be material, volatile material, methane, perhaps being extruded up from below the surface. But, the jury's out at the moment.
Then much further in, we come to this strange moon Enceladus, with its fountains, totally unexpected.
Well, absolutely right, Patrick. We saw these plumes coming out of the south pole of Enceladus. And the story of how we managed to accomplish this goes actually back to early last year. And the magnetometer experiment on Cassini, which was led by Michel Doherty, our Cassini colleague at Imperial College, detected some sort of conducting medium. And after 2 flybys, they deduced that this was actually material actively coming out of the south pole of Enceladus.
Yeah, Enceladus is so small.
Well, yes, this is the surprising thing. We would not have expected an object that small to be basically geologically active and to be producing this material, although there were some indications from Voyager that we were looking at parts of it as a young surface. Enceladus has these tiger stripes, which are ridges which are somehow producing material, actual active volcanism, geysers of material coming out. And we finally confirmed this with the imaging in November last year, when we could actually see these plumes, a sort of crescent Enceladus, and the plumes extending over several hundred kilometers from the surface. So Enceladus, I mean, this is the bizarre thing. There are bigger moons, there are smaller moons. Why is this one geologically active?
I have this weird world with a mountain ridge more than halfway around its equator.
What we knew about Iapetus was that it's this black and white moon, but we never really knew whether it was basically white with a black covering or black with a white covering.
The zebra problem.
Exactly. The leading hemisphere, the one that is going round Saturn, appears to be dark and has a covering. Some of our images that we got early last year, we can see what looks like streaks going in a sort of north-south direction at the boundary of this dark region. And it's suggestive that this is actually a covering. Is the ridge somehow connected with the material? because maybe the material isn't being accreted as it goes round Saturn. Maybe the material is coming from sort of some early volcanism early in the history.
The
of the
height
Ephesus.
of the ridge is just enormous, isn't it? in
Higher than
relative
Everest, isn't
terms?
it?
Yes.
Yes, it dwarfs
How
anything.
on earth do you explain that?
I think it doesn't seem to be active now. I mean, we don't see any evidence of that. But maybe this is something that happened early on. I mean, are we looking at two different phenomena that are completely unconnected, or is there some connection between them? We don't know.
Well, rather close to a much smaller satellite, Hyperion. This really is an oddity.
Yes, we knew Hyperion was an odd shape, and the puzzle was how an object that was as large as Hyperion could still have an irregular shape, because we thought the self-gravity would be sufficient to pull it into a near spherical shape. For example, objects like Mimas have that sort of near spherical shape, and are icy objects. The key is now we've got a measurement of the density, and it turns out to be about 0.6 grams per cubic centimetre, and ice is 1. Therefore, even though it's an icy object, it appears to be underdense. But we see this object that looks like a sort of giant sponge. There are dark regions we can see on the surface, and perhaps they've absorbed more sunlight than the bright regions.
And it's tumbling along in its orbit too.
Exactly. We knew after Voyager and people made measurements of the ship that it's actually rotating chaotically. And that's consistent with the Voyager observations and ground-based observations. So it's not just rotating chaotically, it's tumbling over its axes on a timescale of just a few orbital periods. And we seem to have confirmed that with Cassini.
Picture two, the next icy satellites, Rhea, Dione and Tethys. They're amazing. They're large craters on Tethys particularly.
Well, we know from Voyager observations again, there's this enormous ridge, 1,000 kilometres long on Tethys, the Ithaca Chasma. All these objects we see craters. One thing that has been resolved is the images that we've got of Dione. Voyager seemed to suggest there were these wispy regions on the surface, and everybody would think, oh, this is just some sort of ice coating. Turns out they're actually cliffs of ice and suggestive of tectonic activity, again on what should be a relatively inert object.
And Mimas further in is totally inert.
Exactly.
Death Star.
A smaller moon, but it too is involved in a resonance, and it's closer to Saturn, and therefore perhaps you'd expect more tidal heating. But what goes on?
Carl, John, thank you very much. Don't forget, Saturn is still visible in the evening sky. It's in Cancer, near the larger cluster M44, the Praesepe cluster, and this photo by Pete Lawrence shows it very well, so do go out and look at it. Also remember, Saturn's rings are still well placed, but every year from now, for the next few years, they'll close up, and for a time, Saturn will lose its beauty, so make the most of it while it's there. Next programme, something quite different. There's going to be a total eclipse of the sun on March 29. Not from here, I'm afraid. There'll be a small partial eclipse from here. To see totality, you've got to go abroad to places like Turkey, and that's where Chris will be with our Sky at Night team. But from here, you can see a partial eclipse from about 10:45 to 12:20, and nearly 1/3 of the sun will be covered. But again, as I said before, please remember, the sun is dangerous. Observe it by all means, but take the greatest care. So, meanwhile, let's hope we have clear skies here, and good luck to Chris and the Sky at Night team over in Turkey. So until then, good night.